All right. Just set the timer on my watch so I know when to stop the recording. Yeah, so yeah, we are correct. Okay. So this is actually how you solve a quadratic equation by factoring. You want to make sure you get into standard form. Standard form is what we had in the very beginning. You have the quadratic equal to 0. So you have that, I guess, so you have ax squared plus bx plus c equal to 0. That's what we had in the first slide. Excuse me, the second slide. Then you factor as completely, meaning you factor until you can't factor anymore. That's what I mean. And just like we did, we set each factor equal to 0. You solve, and from each factor, you're going to get an equation. And so, of course, you're going to want to solve that equation. And then it's good to check. I mean, generally on a quiz or test, if you don't check, that's okay. I do recommend you check, though. So, okay, that's an example. Well, that was so much fun. Let's do another one. Okay. So here we have this one. Now, we're going to solve this by factoring. Now, I understand it looks like, I mean, it's already in standard form, right? You have a polynomial of degree 2 equal to 0. So it's in standard form. Okay, now at first, it does look like we're going to have to do factor by grouping, right? But let's get the GCF out. The GCF, right? Remember, well, again, since there's a non-zero constant term, right? We can't factor out x. So x is not in the GCF. So this m is 0. Okay? For b, okay, well, 2 is a factor, is one of the coefficients. 2 is also a factor of 10 and 12. So as we have seen in many examples before, 2 is the greatest common factor of the coefficients and the number and the constant term. Okay? So we have 2 here. We factor it out, as you can see. And so our GCF is 2 times x to the 0, which is just 2. So here I'm factoring it out. Again, I'm showing, all the steps because I don't know everyone's math background here. But if you were to say skip this stuff over here on a test, if you were to skip that, that's fine. You want to show enough steps so that I know you know what you're doing. But you don't have to show as much as I do. So hope that makes sense. But I think it does. All right. So anyway, now by factoring out the GCF, as you can see, we have x squared plus 5x plus 6 to deal with, right? So, this is the leading coefficient's 1. Its degree is 2. So really, it's just like the first one where we want two numbers, right? Whose product is 6 and whose sum is 5. Product is 6, sum is 5. Right? We're trying to factor this down. Okay. So what numbers are going to work? Hopefully you can see that 3 and 2 are the numbers. Right? 6 is 3 times 2. 5 is 3 plus 2. So what did I do? I just replaced this here with x plus 3 times x plus 2. This 2 again came from here. And since this whole thing, the original, was 0, this whole product has to be 0. And you can see that each factor, right, has to be 0. Well, excuse me, we get an equation from each factor. Right? We set each factor now equal to 0. So we have 2 equal to 0, x plus 3 is 0, and x plus 2 is 0. Now, of course, 2 cannot be 0, right? That's impossible. If that happened, then as far as I know, everything would be nothing because you would have 1 equals 0. So this is impossible, so that we disregard. So the only two factors we're going to deal with are x plus 3 equal to 0, and x plus 2 equal to 0. So we have these two to deal with. And it's just like the first example, right? We solve each one. I mean, hopefully it's easy to see that you just subtract 3 from each side. You want to get x all alone. You want to get the 3 out of there, so we subtract 3 from each side. We get x over here is negative 3. Same thing with the x plus 2, right? We want x all alone. So what do? We're going to subtract 2 from each side. Doing so, we get x all alone on the left, and we get x equals negative 2. So from here, we have x equals negative 3. We have x equals negative 2. And again, this factor 2 equal to 0, that's nonsense, so we just disregard that. And so we get two solutions. X equals negative 3, and x equals negative 2. Again, since this is degree 2, right, in a quadratic, you can't have more than 2 solutions because the degree is 2. So if somehow we got 3 solutions, then obviously we did something wrong. And as a check, we have this. Right? So again, all I'm doing is I'm replacing x into the original equation, and I'm checking that the equation does hold. And it does. Same thing for negative 2. So really for us, solving this by factoring, I mean, in the long run, it's really not something new, right? I mean, yeah, we have an extra step. But in essence, it's really not that new, considering what we've done in the course already. But now, let's see something new, and we're now going to see another method for solving a quadratic equation, quadratic formula. What's interesting is I don't know if they derived this in the book, but you can actually derive this formula by completing the square. That's where the formula comes from. You know, it's not just like one day someone wrote it out and then said, oh, well, this is going to give us the solutions, you know, no questions asked. No, you know, it's not like that. Math is not like that. Generally, we like to see proofs for why something is true. And so how do we know this is true? The formula, well, again, it's based on completing the square. I think the book does it. I don't know for sure, though. Anyway, again, this formula says tells you what the solutions are actually going to look like. So how to calculate them using A, B, and C. Remember, A is not 0. So because of that, we can divide by A here. That's fine. What could happen, though, as you'll see in some examples, is the radicand here, B squared minus 4 times A times C. That could be negative. And we already saw that you can't take the square root of a negative number, mostly because we're not allowing complex numbers. Now, does that mean, though, you did something wrong? Not necessarily. You could have a quadratic equation with no real solutions. That is, no solutions that are real numbers. That can happen. Okay. Well, this is a lot to write. So what people generally do is this. Instead of writing negative b plus this over 2a, negative b minus this over 2a, people write this, plus or minus. Okay? That's what people generally write. Just, you know, to keep it compact. Okay, that's good. All right. So this is our quadratic formula. Well, let's start doing some examples. What's nice, again, in this course is you don't have to memorize this formula. I care more about that you know how to use it. I mean, the tests are open book, open notes, of course, but you know, even when I teach this in class, I give the formula. I care more that people know how to use the formula. You know, if you can memorize it, but you don't know how to use it, then, you know, you're wasting your time. But if you know how to use it, then I'm happy. All right. Anyway, so wait, I got to pause the recorder. There we go. Hold on. No, wait. I get to the recording thing.